said, "Oh, I shot at the one on the left first, then the one on the right," our evidence says that he's lying. So maybe there were no thieves, and he stole it himself. That would make him a major suspect. So we can tell, again, we can reconstruct a crime based on how these radial fractures, how they hit each other. It's an important idea. Okay, glass evidence has got to be collected, and if we can, I mean, it's not common, but it can be done. It has been done. We might be able to fit one piece of glass to a suspect piece of glass. The suspect might have some glass with them, and we have glass at the crime scene. We want to collect the glass so we can match the two. If we do, then we know exactly that this glass of the suspect was definitely at the crime scene. This is very true for automobile accidents and things like that, because let's say the suspect or the criminal hit a person with his car, and he's going to drive his car away, and so we know he's going to have the glass on the headlights. If we can take the glass at the crime scene and match it to the glass of the headlights, well, and then we kind of know exactly which car was there doing the crime. So if we can possibly do it, be careful with the glass. Do not break the glass. Try to collect it so it can be matched, possibly with a suspect glass. We not only collect glass on people suspected, on them, but or at the crime scene or with the crime itself. We also collect other glass that's nearby to have a standard to compare to them, so that we know that what the glass nearby looks like, so that if we find glass at the crime scene that is not like the glass nearby, we know it's different. It may have come from somewhere else. So we want to know about the glass that is around the glass of the crime scene, as well as the actual crime scene evidence, broken glass, let's say, at the crime scene itself. So we want to know about the glass around it, not just the glass that looks like it's part of the crime. If we find the glass on someone's clothing, keep the clothing too. You never know what else might be there. You also never know how the glass might have affected the clothing, might have cut it, and there might be something about that. Again, take the suspect's clothing along with the glass. Another mistake here. Oh, yeah, right. No, okay, fine. Of course, glass does break, so make sure when you put it in the container, it's got to be put in protected, like with tissue paper. It's got to be padded so it doesn't break and transfer. Also, you should try to, if you know, based on what was there, let's say you're taking a piece of glass out of a window as evidence, you should mark which glass is interior and which is the exterior. Sometimes you can tell by which one side has paint, but again, it should be marked as the interior, exterior, as long as you're not ruining the evidence itself. That way, the examiner can know a little bit more about the story. So, a little bit of a review. It's not really glass specifically, but you should know some of these chemical ideas: atoms, molecules, mixtures, periodic table, elements, things like that. And you should know the metric system and how it works, and the abbreviations like mg is a milligram, ml is a milliliter. You should know about density, what density is, how to identify glass with density, refraction of glass, and how that works. Know about the kinds of light and how light works as a wave. Understand how glass can be used as evidence. As you know, the different kinds of glass, the soda lime glass, the borosilicate glass, and understand how to work with fractures and how we get information from that, and how to collect glass evidence. For those who have the book and are interested in doing problems, these are the suggested problems.